The depth of water is at a minimum of 5 meters at 8 a.m. At 12:30 p.m., the height of the water is at a maximum of 17 meters. The trig tides question is really typical application for this unit. So all of the applications, what you're going to want to do is you always want to get a sketch of what's going on first. What I find the easiest way to do it is I always set up my axes. Typically it's height against time or depth against time. And I always dot in 3 lines, the low, the middle, and the high, okay? So it's always finding those 3. The middle will be the vertical displacement. From the middle to the high or middle to the low is always the amplitude for whatever the function is, but we got to figure out that function. So I'm going to start graphing this data. So the minimum at 5 meters, well, that's the low, and that's at 8 a.m. So I'm just going to kind of estimate or put a little dot where 8 a.m. is. At 12:30, which is 12.5, because it's 12 and a half hours, is the maximum, which is 17 meters. However long it takes to get from the minimum to the maximum is how long it's going to take to get from the maximum back down to the minimum. So I know it's 4.5 hours from 8 to 12.5. So then if I go another 4.5 hours past 12.5, that's the next minimum, which is also one full cycle. So 4.5 plus 12.5 is 17. So I know that at 17 hours, which is like 5 o'clock in the afternoon, is the next minimum. I forgot to label the high 17, but I'll just do that now. And now because we got the high and the low, which are the max and the min, we can find the amplitude and the vertical displacement. So amplitude's always max minus min divided by 2. 17 minus 5 divided by 2 is 12 over 2, which is 6. To find the vertical displacement, you can always use the formula max plus min divided by 2, but in this case, because I found the amplitude first, and I know then from the middle to the top is 6, and the middle to the low is also 6, I can just go, okay, 5 plus 6 is 11 to get the vertical displacement. If you do max plus min, 17 plus 5 is 22, divided by 2 is 11, always works as well. Okay, for the phase shift, I'm just going to go how far is it to that first maximum. So the phase shift here is 12.5 to the right, and that's just the easiest way. It's almost always, if you want to, you can always do a positive cosine curve, and then it's always just how far is it to the first maximum for your phase shift. Lastly, we just need to find the period. So you can go from 8 to 17 and figure out how far apart it is, but that's basically minimum to minimum is easy to see on this graph, and that's an easy way to figure out one cycle. So the period in this case is 9, so the b value is 2 pi over 9. And now we can write the equation for the function. So d for depth equals the amplitude 6 cos 2 pi over 9 t minus 12.5 plus 11. Okay, for the rest of this example, we're really just going to be punching things into Desmos or into a calculator and finding our solutions. So for C, we want to find the depth of water at 2:45 p.m. And times, we need to make sure we convert them to how many hours is it in total past midnight. So 2 plus 12, because it's 2 p.m., it's 2 in the afternoon, and then so it's 12 noon plus another 2 hours. So 2 plus 12 is 14, and then what fraction is 45 minutes of an hour? So 60 minutes in an hour, 45 divided by 60 is 0.75. So then this is actually 14.75 that we want to sub in for t. There are a couple ways to do this. So you could just substitute 14.75 in for t in that equation and just punch it into your calculator, but I'm going to put everything into Desmos. So I'm going to enter the equation for the function in first. D is going to be y and t is going to be x. So I'm just putting in y equals 6 cos 2 pi over 9, and I need the brackets around everything that's going to be inside cos for Desmos. So then there's the x minus 12.5 instead of the t minus 12.5 plus 11. And I can just, with Desmos, you can just kind of zoom in. So that's what I did. Now I want to put in t equals 14.75. So I just graph that on the next line as x equals 14.75. And then right on the graph, just tap that intersection and it gives you the coordinates of the point, 14.75 comma 11. So that's telling me the depth is 11. So there's our answer, D equals 11. For the last part, we want to find at what times is the depth 7.5. So I'm going to graph y equals 7.5. And then we're just going to, again, once it puts in that horizontal line at 7.5, we just tap on the intersections. What we're also going to do is we're just going to find the first couple intersections, the intersections for one cycle, and then we can use the period 9 to find all the other intersections. So I find the first intersection is at 0.36 seconds, and the second intersection is at 6.64 seconds. And then that's all we need. Those are the intersections for the first two cycles, and then we can use the period to find any other intersections. So basically, we're just using the period 9 to find coterminal angles kind of thing. So I'm just going to add 9, I get 9.36, add 9 to 6, I get 15.64, add 9 to the 9.36, and it's 18.36. Add 9 to 15.64, and I get 24.64, which is past 24 hours, so I'm not going to use that. Now we got to convert these times into hours and minutes. So 0.36 of an hour times 60 minutes an hour is 21.6, so 22 minutes. So this is like 12:22 a.m. 6.64, I'm just going to take the 0.64 and times 60, so it's 38 minutes. So then this is 6:38 a.m. 9:36, well, it's the 0.36 again, which I know is 22 minutes, so it's 9:22 a.m. 15.64, well, that's 3 in the afternoon because it's 3 hours past 12. 0.64 gives me the 38 minutes, so that's why it's 3:38 p.m. 18.36, well, 6 hours past noon, so it's 6 p.m., and then the 0.36 is 22 minutes.